designed by Carl Shapiro and Joe Farrell. And there's sort of an ongoing process of improving these guidelines. And I expect that guidelines in the future will incorporate new ideas, maybe even some of the ideas we've been talking about here about selection and so forth. Who knows? OK. So I want to briefly talk about the approach to merger analysis that's embodied in these guidelines and that deals with differentiated products. Therefore, the way that these guidelines try to think about things is to think that really what a merger does is it consolidates the ownership of a product, two products, rather than completely eliminating them. And it tries to figure out whether the merger will, how the merger will affect competition in this case, right? The simplest way to look at this is just to focus on two merging firms, which is sort of a bit like monopoly, like the reason why we would look at a monopoly model when we are just trying to think about the behavior of a single firm. If we're just trying to think about two firms, looking at a duopoly model is a pretty useful starting point. I'll incorporate other firms and other assumptions later, but let's think about a Nash and Price's case. Now remember that before the merger, firms are going to charge a markup in that case, which is equal to the quantity divided by the partial derivative of their quantity with respect to their own price, right? Now, after merger, the firms are going to set theta equal to 1, right? And so they'll set quantity plus their markup times, because their effect on price, when they increase price, right? OK, so after the merger, they set theta equal to 1. So that means that they set the ratio of the dot product of markups with the effect on quantities over the dot product of quantities times the effect on prices equal to 1, right? And so the effect of quantities of a change in price on price is just their quantity multiplied by 1. And the effect on markups is how much they affect the two quantities multiplied by the two firms' markups, right? So what that gives us is they set price equal to marginal cost. Sorry, equal to marginal cost, because that's in my markup, plus my marginal surplus, right, which is my quantity divided by this here, plus my diversion ratio, which is the ratio of these two quantities, times the markup of my merger partner, right? And so this expression is the same as this one, except that you've added in this diversion ratio between the two products multiplied by the markup of the competing firm, right? And that product is called upward pricing pressure. It's basically the opportunity cost of making a sale, which is added by the merger. The idea is that before I merged, I didn't take into account the fact that every time I sold a hamburger, there was one less hamburger, or maybe less than one less hamburger that you would sell, right, if you're my competitor. Like every time McDonald's sells a hamburger, there's some probability that the person would otherwise have bought a hamburger from Burger King. If McDonald's and Burger King now merge, right, there's sort of a partial hamburger multiplied by the markup that Burger King earned on that hamburger that is lost profits to Burger King that's now internalized every time McDonald's makes a sale. That raises the effective cost to McDonald's of making a sale, and of course they're likely to pass through that cost onto consumers, right? And so the new merger guidelines basically ask for people to measure this upward pricing pressure, to measure the effect of a merger, right? OK. So this gives sort of a basic flavor of how you can analyze mergers with differentiated products. But we left out the fact that there were other firms in the industry, the fact that there might be conjectures and collusion going on. And you can add these relatively simply, given what we've done before, by basically defining a notion of the residual demand elasticity. Rather than just this partial derivative, you can say, how much do I anticipate that my quantity will change when I change my price, right? And then the pre-merger equilibrium will just be that total thing taking into account the conjecture, setting your markup equal to your quantity over that derivative, right? Post-merger, though, when you merge with another firm, you're not going to anticipate that their price changes in response to you changing your price, because you're holding their price fixed because you now own them, right? So we can define a new derivative, which is once the firms have merged, what is the change in my quantity when I change my price, holding fixed the other guy's price rather than allowing it to adjust according to my conjectures, right? And we can derive the same post-merger first-order condition as in the previous analysis, except now we just take the derivatives with this superscript of the merger, which says once I hold fixed the price of my merging partner and allow all other firms' prices to adjust, what is the effect of my changing my price on quantities, right? Okay. So now we can again look at the difference between the pre and the post-merger first-order condition to derive something like this upward pricing pressure, right? The first term is just like upward pricing pressure. It's the diversion ratio multiplied by the markup. And the second term is how the fact of the merger changes my market power on my own product. So there are basically two changes that occur. One is that you have this generalization of UPP, where now the diversion ratio holds fixed the price of your merging partner, but allows all the other firms' prices to adjust as you conjecture that they will. The second term, which we call end of accommodating reactions, is the fact that if you had been expecting some accommodation or potential punishment from the firm that you're merging with, that goes away now that you're merged. Right? Basically, once you're merged, you guys can perfectly collude. So there's no sense in which there's like a conjecture associated with that firm. So this term will tend to reduce your market power because effectively it's ending a conjecture. Because once you're holding fixed the price of the other firm, you no longer have this market power coming from the fact that if I raised my price, I anticipated they would raise their price too, and that made my demand more inelastic, right? So one thing to notice is that the existence of conjectures or collusion makes this term larger, because if I hold fixed the price of my merger partner but allow other people's prices to go up when we merge, then that's going to lead to a greater diversion when I raise my price to my rival's product, because he's holding his price fixed, but everyone else is colluding and raising their prices. On the other hand, if we're colluding, it's also going to make this term larger. So these terms may, to some extent, offset each other. And the real key effect may actually be from the difference between how much I'm colluding with the person I'm merging with and how much I'm colluding with other people in the industry. If I'm mostly colluding with the person that I'm merging with, then this effect is going to dominate. The effect from changing the conjecture I expect from my merging partner. But if I'm mostly colluding with other people in the industry, this effect, the change in this will dominate. And so whether UPP overstates or understates the collusive effect, the pricing pressure depends on whether I'm more colluding with the person I'm merging with, in which case UPP will overstate the effect, because intuitively, if we're already colluding, it doesn't matter that we merge. On the other hand, if I'm mostly colluding with other firms, UPP may actually understate the effect. Okay. So in practice, how do we actually measure these things? One way is you can look at internal documents within the company where they might actually discuss how much, if they raise their prices, do they think would go to various other firms in the industry, or how do they think other firms would react to them changing their prices. Another way you can do it is you can try to get data from consumers or from the internet. So you can ask consumers, if this price rose, which other products would you purchase, right? Even better than that might be that on the internet, you can get data on people who bought this often also bought this or bought this instead of this. And that might give you a sense of the diversion ratio between the products. In auction markets, you can look at when one person just lost the auction, who is the person who most often won in their place, right? That gives you a sense sort of the diversion of the auction sales between the two firms. You can also do econometric models. I don't know if any of you guys are taking the I/O field, but a lot of those are on demand estimation. And basically what those do is they look at times when firms' costs changed, and that induced their prices to change. And they look at how consumers substituted between products in those cases. OK. So one difficulty in doing that is that the relevant diversion ratio when you have Nash and prices competition is holding fixed the prices of all the other firms. If one firm changes its price, what happens holding fixed the prices of all the other firms? But the problem is that when one firm's cost goes up, typically other firms will change their prices. And so that doesn't let you get a clean measurement of what would happen if that firm increased their prices and all the other firms held their prices fixed, right? And so an alternative approach was proposed by Bresnahan in 1981. And he came up with the idea that, when the way that firms form conjectures about how other firms will react to them raising their prices is by looking in the past at when their cost rose, and therefore they raised their price, what did the other firms do? If firms form their conjectures that way, it's really easy for us as econometricians, right? Because then we can just look at the cost shock and see the total effect in equilibrium that had on that firm's quantity. And that's going to be the relevant thing for that firm. Because if they're forming their conjectures about how other people react to their price increases from previous cost shocks, then we can form ideas about that by looking at the previous cost shocks, right? So this is called the consistent conjectures hypothesis. And in fact, you can almost think that the other models that aren't consistent conjectures are a little bit strange. They're saying, well, even though when I've raised my prices in the past, other firms have increased their prices, I'm going to act as if they hold their prices fixed when I increase my prices, right? So in fact, I think this is a very logical way to think about what's going on, and it makes things much easier econometrically at the same time. But for some reason, it fell out of fashion because of various things that went on in game theory. And I think an interesting thing is to try to bring this back. There's a really nice empirical paper based on this by Baker and Bresnahan, who said, well, look, if we're looking at a merger just between two firms, all we need is cost shocks to those two firms if you take this approach, right? Because when we get cost shocks to those two firms, that will show us everything that happens in terms of the reactions that the firms anticipate from the other firms. And so the demand system that's relevant to those two firms in terms of determining what prices that they're going to charge after the merger is just the one that's revealed by cost shocks to those two firms. OK. Now, we don't just want the opportunity cost associated with a merger. We actually want to know how much that's going to change prices, right? But we know well how to translate changes in cost into changes in price, right? You just multiply by a pass-through rate. However, there's two small complications here, one of which is that a merger doesn't just push up the prices of one firm. It pushes up the prices of multiple firms. And the second is that each individual firm raising its prices may cause other firms to raise their prices strategically or directly through conjectures, right? So you need an actual matrix of pass-through rates to affect this, to determine this, right? So each element of this matrix is the effect in equilibrium that one firm's cost increase has on another firm's price. OK. So then you can recover the change in prices in the industry from the generalized pricing pressure that we derived by just multiplying it by this pass-through matrix. I'm using matrix here, but this is really just the generalization of the simple idea that if you have a cost shock, you multiply it by the pass-through rate to get the price change. Okay. And in the case of what I said about consistent conjectures, where we use these cost shocks to measure what the firm's demand patterns were, we could use those cost shocks also to measure what the pass-through rates are. Okay. So Daiichi, how would we measure how much these changes in prices that we derived here impact consumer welfare? What's the effect of that change in prices on consumer surplus? Think of when, in basic price theory, we try to measure changes in consumer surplus from changes in prices. How do we do that?
You look at how much quantity decreases.
Well, that's social welfare, right? But for consumers, we know that by the envelope theorem, how do we calculate the change in their welfare? It's just the quantities times the change in prices, right? That's the idea behind the CPI, right? Is that we take the basket of commodities that people are buying, and then we multiply that by how much the price has changed. And that's how much consumer welfare fell by, right? The change in consumer surplus is just we multiply these changes in prices by the vector of quantities, right? And if we want to turn that into sort of an index, we can divide by the current value of prices and quantities. Now, Vershank, how would we think about social welfare if this is consumer welfare?
Would it just be the change in consumer welfare plus the change in producer welfare?
Well, that's one way you could do it.
So, like Daiichi was saying, if you have to look at the entire change in quantities.
Yeah, the change in quantity. And then what do you multiply the change in quantity by to get the change in welfare?
Change in price? Or
Close.
The marginal change in price?
The markups, right? Right? Because remember that the markup is the marginal social value of a change in quantity, right? Because that's the distortion that's being induced by the monopoly, right? Okay. So if you if you take this stuff and you multiply it by the demand system that you found before, which tells you how the prices affect the quantities, and then multiply that by the markups, you get the change in social surplus, right? So all this stuff is basically just the same as the monopoly comparative statics we did, except that there's a matrix thrown in there. And the benefit of doing things in these normative terms rather than just looking at the opportunity costs is that we could actually incorporate some of the effects we were talking about earlier, right? If we just look at these opportunity costs, well, we know something will happen to prices, but we don't know what are the costs and benefits of that happening. Whereas if we have these other distortions, we could sort of add them all up in an equation, each weighted by its relative importance, right? So a very active area of research is trying to, I think, incorporate some of these other effects into these merger analyses because they're used very often in practice. Anyway, thanks, everybody.